Greetings everybody. Myself Palkumar Pathak. Welcome to LeetCode problem solving series. Today we are going to solve today's daily question 2657. Find the prefix common array of two arrays, which is a medium level of question, and we will start by understanding it properly. Then we will move to the brute force approach for the problem, and at the end of the video we will also check the most optimized way for solving the problem. So let's just start by understanding what our problem is trying to say. So we are given two input arrays A and B, which only contains integer in them. Okay, and we are given in the constraints that a dot length and b dot length are exactly equal, which means a and b contains equal number of elements in them. Now we also have another constraint that inside the a and b, the elements which are present, all of them are ranged between 1 and a length of the array only. Like if the a and b's length is 4, then every element in a and b both will be present between 1 and 4 only. Okay, and the size is 4, so which means that every element will be 1, 2, 3, 4 and like 1, 2, 3 and 4 only. But the thing which will make a and b different is the position of every element. Like where one is positioned in a and where one is positioned in b, it will be the only thing which will make a and b different. Okay, this length of a and b can be ranged from 1 to 50, which means that elements will also be from 1 to 50 only. So this is our complete input constraints, and our task is that how that array will be filled is that inside the answer array, for every index we should have an integer which shows that how many elements are present between a and b till index. Okay, let me show you how. See, for the first test case, okay, we have the size 4 of a and b, which means that every element will be 1, 2, 3, 4 only. So in a we have 1, 3, 2 and 4, and inside b we have 3, 1, 2 and 4. These are our elements. Now as I mentioned, we will again return an array, okay, which will also be the exact same length a and b. Now what our answer array will contain is that, as I mentioned, for every index we will have an integer which shows how many elements are common between a and b till that index. Okay, till that index from starting. So for the first index we will check if we have first elements of a and b common or not, which are not common in a. So we have 0 elements common till a first index from 0. So we will have 0 as our first element in the answer array. Now what we have on the second or we can say first index, which will be our second element, we will check if we have any number of common elements from 0 to first index or not. That count of common element, that count will be our second element answer array. Okay, I hope what you are understanding what I'm trying to say. Okay, as I mentioned, we will check if we have common elements from 0 and first index of a and b or not, which we have. We have both the elements common. 1 and 3 are exactly present on first and second element also, first and second index also in the b. So we have common count of elements equal to 2. So 2 will be present at the first index of our answer array. Okay, this way we have 3 common elements from 0 to second index. So at the second index of the answer array we will have 3, and obviously all the elements will be common of a and b for the last index. So we have 4 elements common. So our 4 will be our number which will be present in the last index of the answer array. This way, at the end of the code, our code that we write, we should have an array which contains the count of all the common elements from start till the last index. Okay, and that will be our array which will be returning at the end. Okay, I hope you will understand what I'm trying to say. So this way we need to solve this complete given problem. So let's just now move to the brute force part way to solve this we'll obviously need, see, we have mainly 2 ways, okay, of solving the brute force, like solving this problem in the brute force way. Okay, and first one is that we will be using 3 nested loops. Okay, this is the most common way to solve this problem. Okay, many of you would just think this, why 3 we can say nested loops. Let me just show you. Okay, first of all, obviously we will have a vector which will be returning at the end. Okay, let's just name it as answer. Okay, now what we'll be doing using 3 nested loop is that first which will be used for iterating from start to end. Okay, we have exact same number of elements, so we will take any one of A or B to like iterate through the loop. Okay, like we will start obviously from 0 and we will either move to A dot size or we will move till B dot size, because both of them are equal, so it doesn't matter much. Now during that iteration, like from start to end, we will take every element of A, or we can do the same thing with B also. Okay, I'm giving an example. So we will take every element of A and then we will check if it comes till we can say current index of the nested loop anytime in B. Okay, then we will increase the count, which we will be adding in the answer array. Okay, during the iteration. Let me just show you what I'm trying to say. See, inside the main loop, we will use a nested loop. Okay, which will again also run till we can say current index only. Like it will run till I. Here it will be J. Okay, yeah. So J will run till I, and it will start running from the first index only. So for the first index, let me just dry run for you. Okay, so that you can understand this three nested loops approach. So we will start by from I equal to 0. So I equal to 0 here. Okay, now J is also equal to 0. So there will be only one iteration. So we will take this one and we will check if it comes in the first index of or B or not. No, it doesn't come. So count will be 0. And inside this, okay, here let me just complete the for loop. Okay, so inside this we will again push that count inside our answer dot push back count. And why we need to use a nested loop, another nested loop inside these two loops also, like here, this will be needed for iterating through the B part. Okay, because it was our one element only for the first iteration, but for the second iteration we have two elements, so we need to check one for both the indexes of B and then 3 for again both the indexes of B. So this way, for each and every element we need to pass through B again and again. So that passing again and again, we also need another loop inside these two loops also. So I hope you understand that we need how we will be doing using these three we can say nested loops. Okay, but obviously you would have just guessed it that it is too much redundant. Okay, for time, because we are completely being dependent on time only for solving the problem. Okay, we are only using a single, we can say, count and a single vector, which is must needed. So we are not much dependent on time, and we are taking too much we are not much dependent on space. Okay, because we are using only a vector and a count variable, and we are completely dependent on time and time only, because we are using order of n cube. 3 nested loops equal to order of n cube, which is too much time. So instead of going through that way in the brute force part, what we can do is that we will divide our complexities of brute force approach into time and space, like by taking some time and by taking some space. So some time means instead of 3 nested loops, we will be using 2 nested loops only. And instead of checking again and again by using a loop, we will have 2 vectors. Okay, this way we can take some of the times complexity and give it to space, so that we can just divide them. Okay, it will be much easier for our brute force part. So as I mentioned, what we'll be doing is that we will obviously have an answer vector. Okay, it is must needed. Okay, which will contain the count. Now count won't be declared outside our main for loop. Why? I will just mention now. So there will be our main loop. Okay, which we'll be using again A dot size or B dot size, anything can we can say use, it doesn't matter. So inside this main loop there will be the count declared here. Okay, now why I'm declaring it here? Because we are using vectors. Now how vectors can save some time for us, like order of n square instead of order of n cube. Why this can help us? Because instead of using a single for loop again and again for passing, we will have 2 vectors. Okay, one for A and one for B. Now what these vectors will have is that let's say we are at this index, like second index of our A. Then we will have a vector for A which will have every element from start index to second index, like this much. Okay, there will be a vector. Let's just name it as, okay, let me just write code side by side also. So as I mentioned, J will start, the nested loop will start from the 0 and it will work till current index, which will be I only. Okay, according to our condition and according to our rules. Now inside this, as I mentioned, we will have two vectors. Okay, again both of them will be integer. Let's just name the vector for A as A clone, because it will be a part of A, so A clone, and another for B, which will be B clone. Okay, now what the A clone will have is that, let's say we are at second element or first index. Okay, we have I equal to 1. So what A clone will have is that it will have every element from starting index to first index, because we are at first index. So A clone will have 1 and 3. Okay, and during that B will have 3 and 1. Okay, now so that we have two vectors containing every element from start to current index, what we can do is that we can use find method. Okay, find function, which we have in our algorithms library. Okay, find function help us to check if a single element that we want to check, if it's present inside two vectors that we want to check, if it's present or not. Okay, if it's present, then it will return the index, okay, of that element. Or if it's not present, then it will return the array that in which we are checking dot end, like it will return the last index. Okay, this is the, we can say, property, or we can say a method which we have in the algorithms library, which is find. Okay, I will explain much more while coding. So for using that, obviously we need to store the elements from starting to current index inside A clone and B clone. For doing which, instead of, like, we can use a single for loop also. We have two ways of initializing a vector. Either we can use a for loop for inserting every element one by one, or instead of using a for loop for inserting, what we can do is we can directly write brackets. Okay, and here we need to store elements from B, so we'll write B dot begin. Okay, so it will start inserting every element from the beginning of B, and it will end, like it will be containing last element till the current index. So for we can say accessing that current index, we will use B dot begin plus I. Okay, or it will be B dot begin plus I plus 1, because if we only write plus I, then it will run to store only till this one. Let's say we are at first index, okay, of A. Then if we write B dot begin to start, so it will start at 1. And if we write B dot begin plus I, so B dot begin plus 1, so 0 plus 1, so 1. So it will store every element from 0 to 1. So it will be storing 1 and 1 only. It will not store this, because it will end at the storing part. This is a property. Okay, this is a property of the vectors, this syntax, that it will store till that index, but it will exclude that index. So for including that index also, we need to write plus 1 here. Okay, and the same thing will be followed for the A also. So A dot begin and A dot begin plus I plus 1. This way A clone will have every element from starting to current index, and B clone will have every element from starting to current index of B. A clone will have of A, B clone will have of B. Now as I mentioned, we will be using an if and the find function. Okay, find function. Now for using this function, we can either take B, okay, and compare every element if it's present in A or not, or we can do vice versa. Like we can take A and take every element of A and check if it's present in B or not. We will be doing it with A. You can test it by yourself for B also. It will exactly work the same way. Both of them are equal things. Okay, but we will do it for A just for no reason. Okay, so as I mentioned, we will take A as our reference, and for every element of it, we will check it if it's present in the B clone or not. So instead of A, okay, here it will be A clone dot begin. Okay, so we will take our A clone vector as reference, and we will run till A clone, okay, dot end. And during that iteration inside the find, we will just simply check if the current element of B clone, which will be B clone of J. If that current element B clone dot J is present between A clone dot begin and A clone dot end, which means that we are checking if current element of B clone is present anywhere in A clone, then simply increase the count. So count plus plus. Okay, now here it, as I mentioned, for checking if it's present or not. If it will be present, then it will return any index, some index. But if it's not present, then it will return A clone dot end. Okay, so we will write this way, that if it's not equal then A clone dot end, then it means that it have returned some index. So if that's the case, increase the count, and if that's not the case, then simply move to the next we can say iteration or next element of the B clone for checking. So after increasing the count and after completion of this nested loop, we will have every common number of element present in A and B from 0 to current I. After having that, we will simply we can say push the current count inside our answer vector, which is our simple task. Okay, I hope you are like understanding what I'm doing here. So inside this answer, we will simply push our count. Okay, so this way, at the end of this complete loop, we will have an answer vector, okay, built from scratch, which fulfills our given condition, which contains every common element at its particular index from starting of A and B, the common number of common count of element between A and B from start to the current index. So we will simply return answer at the end of our code. Okay, so this is our complete brute force part. Let's just test it for the main test cases. Okay, let me just run. So yeah, it works for the main test cases. Let's just submit the code and take for the internal edge cases too. Okay, so yeah, it works perfectly. But as you can see, it is distributed between, like, the time and space, both of them are exactly equal. It is taking this because obviously it's the brute force approach, so it won't be much optimized. So this was a complete brute force way for solving this problem. Okay, today's daily question. So let's just remove this. Okay, so this was a complete way of brute force to solve the problem. Let's just move to the most optimized way for solving this problem. So in the optimization part, what we can do is, obviously we can't use a single we can say a single nested loop, like 4 and inside that another 4, because it is the part of the brute force way. So for optimized way, what we can do is, see, we have some properties with us for as a part of constraints, which is that we have every element from 1 to the we can say length of A and B only. Okay, which can help us too much. How? So what we can do is that we can have a frequency array. Now what that frequency array will have is that, and how it solves the problem. Let me just show you. Okay, see, like I will use the whiteboard. So what we'll be doing, let me just dry run for you. Okay, see, in the optimized approach, we will have a frequency array as I mentioned. So okay, let me create one for you. Frequency, okay, and its size will not be equal to the size of A and B. It will be 1 plus than the current size of A and B. Why? Let me just give you the reason why. Because see, our array will, every array is 0 with 0 index. Okay, and we are storing frequency. So for storing that, we will be using the index as our reference. Okay, how? See, we will let's say we are having 1. So what we'll be doing is that frequency of 1 plus plus. So it will increase the frequency of 1 and it will store it at the first index. This way, every element's frequency will be stored at its respective index in the frequency array. So you know that 0 is never going to be coming in the A and B. Any element will not be equal to 0 and 10. So literally no use of 0 index in the frequency. So for ignoring that and having an extra index to store, and for not making it much complex, okay, we can have exact size too, but it will be complex for us to iterate and then check. Okay, so instead of making it complex, we will simply just increase the size of frequency array by 1. So we will write a dot size plus 1. Okay. Okay, and at the start of the code, every element's frequency is obviously 0. Okay, so we will initialize it as 0 only. Okay, every element's frequency completely 0. Now, how we'll be using it in for optimizing our code is that, let's say we start by iterating in A. Okay, we can iterate and repeat this process for B also. Vice versa things. Okay, we can either take B as reference and do checking for A, or we can take A as reference and do checking for B. Everything can work, but we will be doing it with A for now. Okay, for just taking a reason. So let's say we start iterating from A. A is first element. So A's first element is 1. So frequency of A of 0, which is frequency of 1 plus plus. So what will happen? This will be converted from 0 to 1. Okay. Now again, first element of B, like we are taking every index of A and B one by one and increasing by storing its frequency. And during that increase only, we are checking if any time it's equal to 2, then increase the count and store that in the answer. Okay, how? I'm showing. See, first for this element it's increased. Now for this element, like for the 0 index of B, frequency of B of 0 plus plus. So frequency of 3 plus plus. So this will be converted from 0 to 1. Okay, now for after increasing for this, okay, I just missed one thing, that after increasing and increasing the frequency for 1, we will check if frequency of A of 0 is equal to 2. No, it's not equal to 2. So move to increasing for B. So then we will increase for B. So frequency of B of 0 plus plus, frequency of 3 plus plus. So it will be converted from 0 to 1. Then again for this element also we will check if frequency of B of I or frequency of B of 0 is equal to 2 or not. No, it's not equal. If it's equal, then increase the count. Okay, it's not equal for this iteration. So skip the iterations, and before skipping and moving to the next iteration, push the count, current count inside the answer. Current count is 0 because we haven't encountered any frequency equal to 2. Count is equal to still 0. And then just push the count, like just push 0 inside the answer array. So for the first, or we can say 0 index, for the first element of answer, we will have first test case. Okay, I hope you are understanding and getting what our approach is doing, what our code is, how it's solving a problem. Okay, so now for the next iteration, again the same process repeated. Frequency of A of 1 plus plus, frequency of 3 plus plus. Now the actual thing happens. Okay, it's already 1, so it will be converted to 2. Now after checking if A of frequency of A of 1 is equal to 2 or not. Yes, it's 2. Frequency of 3 is equal to 2. So count plus plus, because now you know that yes, 3 has already come in B and 3 is in A also according to current iteration. So we know that yes, it is common from start to current index. So count plus plus and count equal to 1. Okay, next thing, frequency of B of 1 plus plus. So frequency of 1 plus plus, again this will be converted from 1 to 2. Again same check, if frequency of A of 1 equal to 2 or not. Yes, frequency of 1 equal to 2. So now we also know that yes, 1 is also another common element between A and B. 1 has come in some previous iterations. Okay, we know that now by using that if. So count will be plus plus again. So count now is equal to 2. So for this index, for the first index of answer, we will push back we will push back count, which will be 2. So we will push back 2 inside our answer, and 2 will be present in the first index of answer. As you can hear, 2 is present in the first index. Okay, I hope you are getting how our approach is solving the problem perfectly. Now for the next index, again frequency of 2 plus plus. So frequency of second index plus plus, so 1. Again for this thing, I hope you understood how it's going to be at the end. So for this 2 also, it will also be plus plus. And after checking for B, it will also know that yes, it is also 2. So increase the count by 1. So count will be equal to 3, and 3 will be pushed in the answer array. And again, after this iteration, last iteration also, the 4 will also be 1 for the A and then 2 for the B. So again it will be 2. So again count will be plus plus and 4 will be pushed at the end of the last iteration. And after ending that main for loop, we will have our complete answer vector built from scratch containing every correct frequency, that how it's coming and how many common elements are there from start to current index of answer. Okay, now as I mentioned, now the problem is solved. Okay, I hope you understood what our approach is for optimized way for solving this problem. And now let me just give you the proof that yes, as you can see, the 0th index is just useless at the end of the code too. So we are not going to use that and it will be just as it is. Okay, so this is our complete optimized way. Let's just go for the coding part. Okay, the optimal code solving the problem. So as I mentioned, we will have again answer vector which will be int only, and it will be named as answer. Now count can't be inside the for loop, okay, because our count is a global variable which is being controlled according to every current iteration, for which count will be initialized outside of the main loop only. Again, a simple single for loop for the optimized way, which again it can be from 0 to a2 size, a dot size and b dot size also. Okay, it doesn't matter as I mentioned. And I will be plus plus. As I mentioned, we will have first of all a will be our reference. Okay, so frequency of a of current I plus plus. So now, okay, now this will be equal to 1. Okay, I just forgot one thing here. Is that frequency array. Okay, frequency array is, it's the main thing which I forgot. Okay, so let's just declare our frequency array. Okay, frequency, it will be here vector int, and it will be named as frequency, and it will be initialized as 0. So like by writing this syntax, we are initializing every element of frequency as 0. Okay, so after this, I hope I think I did some mistake. Okay, instead of vector it is a array. So int frequency of size, as I mentioned, a dot size plus 1. Okay, I'm really sorry for the mistake, and it will be initialized every element as 0. Okay, now I hope you know that this syntax initializes every element of frequency as 0. So for the first test case we will have 5 elements. Now as I mentioned, after increasing the count for a, we will check if frequency of a of I, okay, here it will be capital A of I, if that's equal to 2. Okay, if that's equal to 2, then increase the count by 1. Okay, and then after taking the first element of A, move to the first element of B. So frequency of B of I plus plus. Okay, and after increasing that, again check that if if frequency of B of I is equal to 2, then again increase the count. Okay, our simple task as I mentioned earlier. Now we will simply push back our current count inside the answer vector. Okay, simply sorted complete optimized way for solving the problem. Okay, I hope you completely understood what our code is doing. Okay, I completed dry run for you for every index, that we are taking every index A and B one by one. After storing continuously, we are checking again and again if there is any point of time where our current frequency is equal to 2, increase the count, because now we know that yes, the element that we are having currently is common between A and B from starting to current index. So for that, increase the count, and at the current iteration, push the count in the answer. Okay, this way at the end of this main for loop, single for loop, we will have a complete answer rebuilt from scratch containing every we can say frequency of common elements of between A and B till the index, the respective index of answer in the index of answer. Okay, so this way our complete optimized way can be completely been possible for solving the problem. Let's just run it if it works for the main test cases or not. Okay, let's for the main. Okay, there is some error. Uh, okay, I think instead of using an array, we should use vector only, because I think if we are doing a dot size like for initializing vector, it makes problem. Okay, it is giving. So let's just instead of using an array, let's just use vector only. Okay, it will be much easier to work with that. Okay, again everything will be exact same. It will be just instead of array, we will be declaring it as vector, and again everything as I mentioned will be exact same. Yeah, it thus will be a dot size plus 1, and every element will be initialized as 0 only. This is the syntax to write. Okay, let's just check it for if that works for our approach instead of array. So yeah, it works. So okay, I hope you understood. Instead of using array, we should use vector only. I'm sorry for that. I just like didn't understand it. It can't work. Let's just submit the code for the optimized approach if that works for the main edge cases. So yeah, it works perfectly. Okay, I hope you would have just noticed that instead of 5% it has increased to 60% for both the time and space complexity. Okay, so this was the complete optimized way, optimized approach for solving this problem. Today's daily lead code problem. Find the prefix common arrays of two arrays given to us. So this was the complete approach. If you like the way I explained and I mentioned the problem, please like the video. If you have any type of feedback, positive or negative, if you have any doubts too, you can check or you can put that in the comment box below. If you want to ask me anything, if you have any doubt or anything to ask me personally, you can use my social connection link present in the description of the video. If you want to check other questions too, I have covered just daily question and other many questions. You can check the playlist of LeetCode problem solving series. Many other questions is also going to be added. For checking which, please subscribe to the channel to check every question which is going to be added. For more tech and coding related content too, you can also subscribe to the channel. Thank you for staying till the end of the video. Thank you very much.